Ja, ja, ich gebe das dann. Ich gebe es dir.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heating smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Hello, hello. Good afternoon, everyone. Welcome. Welcome to the event, Coding the Future of Mobility. Happy to have you here, and my name is Seyat. I'm guiding you through this event together with awesome Josie. Hi, Josie.
Hi.
How are you?
Fine, thanks. How are you?
Good, good. Yeah, before we start, a couple of words and remarks. We already had a virtual chapter in the morning, so if you missed that one, it was a very nice fireside chat with the Director of Engineering, Christine from Bosch, and also a nice workshop. If you missed that, no worries, you can watch it on demand afterwards. And now we are in the afternoon chapter, so Josie, what's waiting for us in the upcoming hours?
First of all, hello also from my side. Hello to everybody here who decided to visit us in Vienna, and to everybody who joining us virtual. Yeah, great. The morning chapter was great, as I've heard, and the afternoon chapter will be also great. We have 3 sessions who are all about the future mobility, automotive. But first of all, what is mostly important today, lucky you, you have all the choice to win something today, whether you are online or here with us in Vienna. You can win tickets for the WeAreDevelopers World Congress in Berlin, taking place June 14 and 15. So for you who are here, just let us know if you want to participate at the registration counter at the back. And we will choose the lucky winner at the end of the show, at the end of the last session, as I know. And for everybody who is joining virtually, just be as engaged as possible to win the leaderboard. So please join the sessions, bookmark, tag the sessions, participants, chat with the participant as possible as it is. And I wish you all luck for the
raffle.
Yes.
Yes. So, wow, it's really amazing to be at an in-person event again. And I just want to say a special thank you to one person who made this also possible. I would like to call on stage the CEO of Robert Bosch AG, Helmut Weinwurm. Please, one round of applause for making this event possible.
Hello.
Hi.
Hello.
Hi. I like the haircut.
Yeah, it's 25 years with Bosch. Question is, what will happen the next 10 years with me?
Yeah, okay. Helmut, it's amazing to have you here. Thanks for hosting this event. And just one question out of curiosity, what was your first computer actually? And what did you do with it?
Oh, that's a long time ago. But I believe it was an IBM computer. And I used it for the CAD applications at school.
Oh.
And of course for gambling, yeah.
Okay, but that's not so long ago, I think. Then I also want to be very honest, like everyone knows Bosch as a, you know the Bosch as a brand, obviously. It's a very famous brand. You know the consumer products, the wash machines, the dishwashers, all of these. But I think it's very interesting to see also what's behind the curtain, because in fact, Bosch is also a really high-tech company. That's what I learned while preparing for that event.
Yeah, that's right. Sure, we are a high-tech company. As you said, many people know the consumer goods, washing machines, the power tools, the drilling machines, and maybe the thermotechnology. But important is that we are one of the world's largest supplier for automotive parts and for the automotive industry. And that obliges that we really bring every day the best technical solution and the best and the most innovative products. Yeah, that's a big challenge for us. Innovative powertrains, IoT, artificial intelligence, all these things are challenging us every day. But I believe that we manage this quite well. We have a really good team here in Austria, and we are very successful, and that's really makes fun to work here.
Yeah, that's awesome. So a lot of interesting topics you are working on. I think 400,000 employees worldwide, right?
Yeah, that's right, yeah.
Yeah.
And approximately 75,000 are working in the research and development area.
Wow.
And 1,200 in the development area in Austria. And the great thing is that we will hire this year additional 250 developers, and during the next year 600. So,
wow.
Yeah, you're welcome.
I think
I'm going to switch here because it's my job.
Yeah.
That's right, yeah.
I think that makes you a tech company, I would say. Last but not least, like, what do you think? Like, what's the role of developers nowadays and in the future? How do you see that? What's your personal opinion?
Yeah, they have a very important role, because what they create today shapes us, our life and our society tomorrow. That brings also a very high responsibility. They write the code of our future, and that's the reason why I'm very happy to be here in this event today, and that the event takes place here with Bosch.
Oh, that's some very nice words. Thank you very much, Helmut. I hope you will enjoy the event. Thanks for having us, and yeah.
Yeah, I thank you. Enjoy the event. Have fun. I hope you will see and hear a lot of interesting topics, and yeah, enjoy the food and the muffins.
Yeah, the chocolate muffins have been great last
That's
time,
very
so
important,
just-
yeah.
I hope they have enough. So,
Okay, so thank you.
thank you.
Thank you very much.
Bye.
Thank you.
Okay, then we have one more thing before
Yes, just one important thing. One important thing we would like to let you know at the beginning is also our code of conduct. It's basically be nice to each other, whether you're here on site or virtually. But what we really mean with be nice, we have a short video for you. Have fun, enjoy, as Helmut already said, and let's take a look at the video.
Good, so we've waited enough. So let's welcome our first speakers, our first session about architects, key players of for our future products. So please welcome on stage two amazing speakers, Jochen Hertlein, Chief Software Engineer from Bosch Germany. Thanks for being here. And Sebastian Roche, Lead Systems Engineer from Bosch Austria. The stage is yours. Have fun and see you later.
Yeah, welcome to our talk. We are talking about architects, key player for future products. So Jochen and myself will guide you through some architectural topics, and we want to have this talk interactive. So we prepared a Menti request for several topics, decisions where we would like you to be involved also in our talk. So we would directly jump in.
So, hello also from my side. So happy to be here. And I mean, Bosch means also a bit of a work, and as Sebastian has mentioned, yeah, we would like to involve you in that talk, and for that we have prepared a Mentimeter here. So what you guys have to do now, please take your smartphones. You either can scan that code here and participate. You can even go to menti.com over here. So now it would be the pace, yeah, to really get along. Take your smartphone, scan it, go to menti.com. And actually the question is, starting as opener, what is, in your perspective, the value of architecture? So I see smartphones are rising. That looks very good.
Yeah. If you are far away, feel free to come closer to the boards to get the code. So Jochen, until the colleagues here are answering the question, maybe a question to you. What did you have, from your personal perspective, contact with architects in the last time?
So to be very honest, I'm currently building a house, yeah, and their architecture plays a pretty crucial role, yeah. So the idea is that, I mean, what does an architect for building a house do? Yeah, he does the basic plan, yeah, and tries to get along that you get your ideas of that, what you want to have in that building done, and that you basically, it somehow fits together at that point. So architecture gives, from my perspective, structure and organization to a building. That's my private currently experience, yeah. And we already see, okay, some topics coming up with the value of architecture, yeah. Stability, very interesting, yeah. So stability, architecture cannot be changed that easily, yeah. So you might have to have the decisions on your architecture, your design decisions, done very sophisticated in order changes to an architecture are typically pretty expensive afterwards. Yeah?
Also, structure is a quite important topic. So the architecture brings structure to our products, to our future products, to enable reusability, for example, and also to fit the architecture to our processes, methods, and organization.
Planning, efficiency, performance, that fits also together. I mean, if you have an architecture which does not suit to your business need, what you have, then you have a lot of hassle with that and additional work. And while a lot of interesting pops coming in, maybe we would switch over again to maybe a topic what really happens in life, yeah, to really see what could be there for architecture. And here we basically see there was once actually an example we would like to act a bit as an opener, yeah. And this was somewhere in the switch of the century when we had the Mars orbiter, yeah, which was actually sent out there, where they had the idea from NASA perspective to develop in a worldwide team the architecture, the solutions of this Mars orbiter. And the result was that this was running with a speed of several thousand meters per second into the surface of the Mars. Sebastian.
Yeah, what happened? Why could there be an accident? So the topic is that the navigation station was developed by another sub-team than the climate orbiter itself. So it was a worldwide research project with different locations. The navigation station was developed in meters, while the climate orbiter was developed in inches. So the defect was that the navigation station was communicating over the meters, and the climate orbiter interprets the meters information in inches. And then, yeah, the climate orbiter crashed into the Mars surface with a quite high cost then, because it was not usable at all. The whole project, with total costs of $125 million in the year 1999, was lost because of a bad architecture.
So funny thing, yeah, small decisions which are not designed appropriately, yeah, come to a high impact at that point, yeah. Luckily, we are a bit developing more sophisticated our software anyhow, yeah. I would like to involve you in a second row, yeah, and the idea would really be based on that.
First of all, we have the common statement for today, which should be a takeaway for you. If you think good architecture is expensive, then try bad architecture. This is just the worst case scenario, that a climate orbiter crashes into Mars. That's not our daily life business indeed, but I think it's a good common understanding that good architecture, even if it is expensive, saves money later on.
And if you take something away, then take at least that one. So the question is now, and back to you, please take your smartphones again. What is the impact of architects? Yeah. So in that view, what we have learned right now, yeah, what do you think was what we as architects in our Bosch company, yeah, developing topics for developing solutions for the powertrain, yeah? What is the impact of architects? Yeah.
Okay. What was the impact of the architect at your house, which you're building at the moment?
I mean, so far, yeah, I mean, the architect did a pretty appropriate job. We had some issues, yeah, which resource shortage as well, yeah, so we had some delay in the overall planning. And then also getting along that we get the teams aligned, and also, I mean, that everything fits together. So architect, from my perspective, it's pretty important. And I mean, what's pretty clear, you typically see only that from the outside view, what the architect does, yeah. If like here is 100 Wasser, what looks nice, yeah. But there's a lot of internal thing, what is really important that the architect also needs to clarify at that point, yeah.
We get the first answers right now. So my favorite answer here is the communication. An architect's role is to get colleagues together, to get definitions together. So a large amount of our daily work is communication as architect.
And I mean, this communication also spreads to that extent that different stakeholders, be it from requirements perspective down to the testing and application, have the same view on the system and talking about the same content when they talk about the system. We have the planning aspect here clearly as well, and also the topic about quality, yeah?
Mm-hmm. Yeah, and of course, the design is in the focus of an architect. We are developing design, software architectural design, system architectural designs. We will get to this design part further on, more in depth.
Perfect. Thank you for that feedback. Then we would switch back to the presentation. So, question now you as an architect. Isn't the architecture just drawing boxes and lines between them? What's anyhow interesting about being an architect, Sebastian?
Yeah, the interesting topic is the impact which an architect has. So the architecture here in the center of our presentation shows our focus. But the architecture itself is defined by our business. So the business case is defining how our architecture looks like, the requirements to our architectures and so on. Even more, if we have defined an architecture, this has a huge impact to our processes, methods, and tools. So the way how we develop is defined by our architecture. Further on, the processes, methods, and tools are then represented in our organization. So which teams do we need, how our teams are separated, and so on. And this principle is called BAPO, and this shows the interaction between business, architectural processes, and organization, and their interaction. So an architect has influence on the business, on the process, and even on the organization.
So it belongs all together in that breakdown, yeah? So architecture is not only sitting there and drawing the boxes, it's understanding what is the business needs and align your product towards that, and also giving impact how your organization works. And this, if not fitting together, you are in trouble as seen. So if you look at the example, Sebastian, then what's your view on the ABAPO, yeah?
Yeah, we can show this example here right now. So the business case for our Mars Climate Orbiter project was that we had a worldwide research project to travel to Mars or research the climate on Mars. The architecture was quite straightforward. We had a navigation station located in America and the climate orbiter in space. The processes which was defined on a very abstract level was that the product was developed in 2 separate workflows which are verified independent on each other. And in parallel to the organization and the architecture, also the organization was split up in 2 teams on 2 different locations. In this worst case, the one was designing in inches, the other one was defining in meters.
So what went wrong from architecture perspective?
Yeah, we should have considered, the colleagues there should have considered the whole system as one and defined the interfaces before in a more detailed way.
Especially if you work across countries in different kind of sites, there are typical implicit assumptions you don't get along with, yeah? So that's the point. Clearly, yes, yeah? So, what is architecture more? Yeah, so it's influencing a lot, but still, isn't it all boxes and lines what you draw about that? So what is it? Yeah.
Yeah, architecture covers a lot more than just drawing line defining interfaces. So from principle, architecture starts with the functionality, with the requirements. So by defining the requirements, we are defining our system of interest. The basic question which causes lots of confusion in daily business, what are we talking about? What is our product and what are our stakeholders? The next step after we know what our system is and what requirements we have is the functionality which we have to cover. So we need to define the sub-functionalities and their dependencies of each other. In the next steps, we need to know which information is transmitted. So if we transmit distance information in meters or in inches, if we transport the time in seconds or in hours, for example. And even here, we are defining our system in logical subsystems, most likely the send, sync, act actions, which we know, I guess, quite well in this community. And in the final state, we allocate the functionalities, the logical view, and even the requirements to technical subsystems where we define technical interfaces between specific elements. And this view is defining then the first abstraction layer of an architecture. There are furthermore abstraction layers defined by our technical views, so each subsystem has their own views, and with all abstraction layers considered, we get an overall picture of the whole product from the top-level system requirement down to very detailed elementary requirements further on. In our daily business, we differentiate between most likely a system layer on the top level and hardware requirements, software requirements, and hardware architecture, software requirements, architecture further on.
So just to summarize for a second, yeah. So first of all, understand what's your system, what's in, what's out, who is caring about that system. Second point is what is the functionality done by the system? Yeah, it has to be clearly also with the interaction to the outside. Third one is really understand how do I break down internally my systems, how do they interact? And the last one, I do finally that mapping to the realization. Yeah, so do I implement that in a hardware? Do I do that in software? So this is something what you do. And to have the right separation actually is highly important to avoid unnecessary variance and to really separate that out. Yeah? And the challenge actually what we are facing here, if you look at our electronic controls, what we are doing in the powertrain, I mean, we have this high number of variants what we have to deal with, yeah, with different kind of customers going on and different kind of solutions what we have, and keeping that as a product line together. This is actually the overall challenge what we are facing here. Yeah.
I think we have seen enough theory at the moment. I think we should go to a practical example here.
Exactly, and I mean having an easy practical example, I like to bring again something out of my personal life. Yeah, so I'm a soccer referee. Yeah, so and basically I'm coming from Stuttgart. Yeah, and I mean you might know VfB Stuttgart. Who knows that club? Anybody know VfB Stuttgart? Okay, at least a few hands are rising, yeah, so, okay. So everybody who knows that soccer club is they are constantly struggling to keep their position in the first league, yeah, so they're always at the very bottom, yeah, and they have struggled. But anyhow, as we are Swabian, yeah, we somehow try to come up with innovative ideas, and basically for that, I would like to send my congratulations all of you. You are together with us now the development team for developing a solution for the VfB Stuttgart, yeah, in order that they hopefully might hold the first league for this year, yeah. And the point is actually that we gotta have a system which is called game changer, yeah. So meaning for them that they are able to be in a position to be more have more competitive advantage at that point. So first of all, our system of interest, Sebastian. As you told, yeah, we try to do that. So we have a game changer. What they would like to achieve is actually they would analyze the movement data of their players. Yeah, so how do they behave in a game, in training, and so on, and then finally analyze them. How well do they fit to the tactic it was planned, and so on? How well does it fit? And then plan out of that some kind of match. Tactics, yeah, which they can apply to the game in order to be better than they've done in the past, to be very honest, yeah. So, and then we have to care about the input, yeah. So input is clearly the player, right? And on the other hand, we have the coach, which is basically getting that information, yeah. So clear setup, I think, pretty simple. We know the functionality, what should be done, right?
I think we have forgotten something.
Oh.
So if we just track our players, that wouldn't be sufficient for a real tactical advice. So I think we should also consider the competitor movement and also include this as a requirement.
I mean, clear. That's a very good hint, yeah, and that's also what they triggered. As we're talking about AI and as we try to be more sophisticated, the idea is, why isn't it possible to also read and analyze to some extent competitor games at that point and use that in planning our tactics over here? I mean, it's much better if you know how the competitor behaves at that point, yeah? So this is our setup, the system of interest we're working in, yeah? So we have as input, basically, we have the player on our side, we have the competitor, their players, how they behave in a match, yeah? And we have the trainer on the consuming side, which basically tries to take the input and get out a tactic which brings hopefully the success in the following up match.
Of course, this is a quite easy example, but if you look into our future products like connected devices with cloud services and so on, we have a lot of more functionalities and so on. And the focus on this perspective is to define our system, what we're talking about, to define the interactions which our stakeholders are, and to get an overview of the functionalities and define the functionalities of our system.
So then we have the requirements view, basically. So take now the functional view. So we would like to analyze the movement of the player, right? I mean, that's the first functionality which is visible to the user outside. So the idea is to get the player information, yeah, where they are, how they move, basically, and somehow assemble them over time, yeah, how they move over the playground at that point. And in addition, we have then the analysis. So we analyze basically them against the given tactic. Yeah, does this match? And finally, I mean, it also brings in the stream of the competitor games, which is some kind of reference tactics we would like to analyze against and see how well does this match if we give that behavior information to our players, how they are, and this basically brings out the overall learn tactics what we have at that point. Yeah.
Yeah, the benefit on this view is that we can break down the requirements on different actions and sub-actions and further on to structurize our requirements even more. Also, we get a priority between these actions, so we know which activity has to be conducted first, and then to define scheduling information, for example, further on.
So most of things, we're talking about systems, we're talking about the functionality. I mean, that's the most view what we have. But now looking further about the logical view. Yeah, and if you have the logical view, you basically try to structure your system in a way, okay, I have this way of player tracking, yeah, getting the data into the system. Then you process the data, and then you basically provide the result. What we call that structure is basically you try to separate sense, think, act. Yeah? So really, in order to be a bit more independent, where your source of data is coming from and where you put basically your data at the very end, the idea is to really separate that out. Yeah? So this is a basic structure which might help you in future to be more competitive, but we're going to have an example later how to see it. Yeah? So if we now, for instance, take a solution, okay, we get our player information, you could say, okay, I take a time series of coordinates, yeah, where I have it on my playground. That would be one solution, what I could do, yeah. And I could basically do the similar thing. What I do, I extract basically the information for the players out of the competitor game. Yeah, if I extract it from a video and so on, that would be possible at that end. Then basically I assemble it, yeah, and bring it together. So on the one hand, I get the team position of my own team in different kind of situations, and I do it for the other teams. And finally, the output of the technical information, yeah, and bring it to the point, yeah, just as visualization to have their decision on.
But Jochen, I think it's not the best way to transmit coordinations. I think looking to the functionalities further on, we should transport movement informations in a vector way or something like that.
That would be definitely an alternative solution, yeah. So where you would provide some of the functionality, yeah, more to the sense part, yeah, to say, okay, I aggregate the data in more of a way. And I mean, as you already see, individual player information, then you have to somehow recompile the overall information about the team tactics, yeah. Question, we're gonna see that, isn't it more sophisticated maybe to keep it together, yeah. So already transfer more of the team information at that end. So finally, but look at the technical view, how to realize it. What is the real physical things we run that on, right? I mean, that is a technical part. And there, the solution would be, okay, on the one hand, we have our own players, yeah? And what we do basically, they all get an on-body device, yeah? And we get some data out of them. Yeah, that's the way we get the data. Then we have our cloud, our processing unit, where we all process the data, and we have some kind of display screen where we get the result. Yeah, I mean, we were not able to convince our competitors to wear our on-body devices. Unfortunately, yeah, for that we have to take some kind of other data out of that. And basically the point is, here we have the data of what we take out of a camera system, for instance, where we have to analyze it at that point. Data is transferred via USB or HDMI, yeah? And I mean, clearly we have then separate options how to include the new functionality into that, yeah? So either we extract out the individual player at that point and bring it to the former solution, yeah, or we might have another idea, yeah, to really get some kind of extraction out of the camera system, yeah, and bring that data to that point, yeah.
I think we should ask the community here for advice. Which option should we do?
I mean, as you are all well served with lunch and food over here and drinks, so I would like to switch back and with that, what we have explained, you guys are architects, yes? So what option would you decide? Option 1, to do everything in the sense part, yeah? Or option 2, open a new interface, yeah? And bringing it basically to the second part. That would be my question to you guys. So, I mean, talking a bit of the characteristics, what could go for one or the other, Sebastian?
Yeah, so I would recommend option 1, because then we can reuse the existing solution. We can go for the USB solution, which is existing. We already need this. We have less system interfaces, which we have to maintain, which we have to verify, and so on. but I guess you have also an opinion on this?
Oh, I would go for option 2, right? I mean, it's more extendable, yeah. I don't create any bottleneck in here. I can even go for keeping the complete team together, yeah, and bringing it more to the data processing part, yeah, and really analyze the overall there, then I don't have to rebuild it, yeah. And I mean, as we see here, the options coming in, it's indifferent, yeah? And what's the clue about it? We come back to what Sebastian has presented about the BAPU topic.
Yeah, architecture is not black and white.
Yeah.
You have to make options available, their benefits and their disadvantages, and then decide on your business case, on your architecture, processes, methods, and so on, and then do a definition. But it's not a clear definition at all states.
So for instance, if your business context is, I have to deliver a solution very early, yeah, then you might go for option 1, because you can maybe create it faster, but you might have restrictions for future evolution of the system, yeah. And this is just giving you, in a very short side, an idea about what does it mean in detailed view to be an architect, to take day-by-day decisions, yeah, which you have to balance out short-term decisions with long-term decisions, short-term costs with later costs, yeah, time pressure from customer with that, what means sustainability. That's the goal of an architect, and that is what makes it highly challenging and highly interesting to be in our role at Bosch here over here to act as an architect. So let us come up with a summary, Sebastian. Can we switch back, please, for a second? Perfect.
Yeah. Now we have the final picture of our product. We know the requirements, the definition of our product and the stakeholders, and have the requirements view. Further on, we derived the functionalities and the breakdown to actions and sub-actions further on, and their order in the functional view. In the third view, we saw the logical interfaces and the logical subsystems in sense, think, act separated, and this was allocated then to the system elements we have seen in the technical view in the last view, with the benefit that if we have all these views available, if we have designed the requirement top-down from the requirement to functional, logical, and technical view, we get an overall impression of our systems, independent if it's a system like hardware-software subsystems, or if it's pure software architecture. The principle is the same, independent on the abstraction layer which we are working at.
And this is providing actually the way how we work internally, yeah, and has a lot of impact how the success of that product is what we have. And for that, we are convinced, yeah, that the architects are key players for future products, especially in this VUCA world, in these changing products what we have. And this basically gives us the challenge, yeah, and hopefully even transports it to you what we see that this is a job what's highly necessary for the future in order to bring the product forward. Thank you.
Thank you.
Okay, thank you very much. So let's see if VfB Stuttgart can keep the league. And
otherwise, I'm not guilty, right? I mean
yeah, that's true. The architect. So let's see if we have some questions from the audience here in Vienna. Please go ahead, just raise your hand. You will get a mic and just ask a question. Don't be shy. And while you are raising your hand very slowly, I will ask maybe my first personal question. Like, with all the tools that are coming up every day nowadays, with AI-powered tools and these kind of things, how does the work as an architect evolve? Like maybe in the past you were there with a sheet of paper and wrote some designs and business logic and so on. What are the tools you use today?
It's variant kind of tools, yes. So I mean, one thing you have to separate, you're developing a product, yeah. Then basically the main challenge is, and there we try to definitely use open market tools as much as possible, that every party who is involved in the development of the product has an up-to-date view on the architecture decisions taken. Because otherwise, team A develops in meters and the second one develops in inches, right? That's the point what happens, yeah? So that's the point. For that, we use typical state-of-the-art tools like what you know from MATLAB Simulink or whatever, yeah? So we use those tools and do our architectural design, even for the requirements perspective, like what we do with stores next gen and so on. So this is basically what we do. The challenge comes up basically if we look on our product line. So basically, I mean, we have hundreds of customers, several hundred of projects running in parallel, and we try to keep them properly together without slowing down those what's pretty specific, yeah, but keeping that part together what there. To be honest, there are rarely open market tools available, as that what we serve as magnitude of solution to our customer is one magnitude higher what the typical market solutions are, yeah? And it's a bit of a challenge where we also clearly try to identify for what problems is it usable to use open market tool and where might it be more suitable to also think about own appropriate solutions. Yeah?
Okay, thank you very much. So any questions from the audience? Please, here is one question.
The icebreaker.
Just a second.
Hi. How close to the code do you think an architect should be?
Pardon, can you repeat?
How close to the code
is the architect?
Should a software architect be?
So, point is the following. An architect should definitely have clear understanding and close idea to the code. However, what we experience that if you put code first, then you take design decisions by designing your code, which might not appropriate to the rest of the system. And for that, there needs to be a balanced approach between that, what you have your opportunities for your code to do. However, for your product, that it fits together, there needs to be an upfront alignment before you start your coding, what is required. So it needs to be a balanced approach between both what is necessary from coding perspective in order to fulfill a requirement, and to agree to freeze the architecture upfront before the others start developing. That's the main goal, what has to be done on architecture. You cannot separate them from my perspective, it needs to keep together.
So you two regularly work in the IDE, look at what code is in there, you do code reviews and all those kinds of things?
Basically, yes. So I mean, we do that on a bit of a larger scale, as we have 10,000 software lines developed a year, yeah? We basically have done on that end a lot of automation to analyze the technical debt we have in our system, yeah? And to give a clear guidance, yeah, where you might not have the appropriate state-of-the-art design because, for instance, code has grown too complex, yeah? You might have too many cycles in there, that's one part, or you might have too many interdependencies, you might have non-supported interfaces anymore. This is something what we try to give on that large scale as analysis support to our development. And this is always an interaction. We check from architecture side, where do we have issues, and we try to bring that back to the projects.
Okay, thank you very much for the question. Also for the ones who join us virtually, just make sure to take the opportunity to also ask questions through the chat or through the Q&A tool. Right beside the stream, you can open it and then just type your questions. Follow-up question to this one. Do you, as architects, do you also do some coding stuff, for example, to check the options like prototyping and see like if the options you propose would even work out?
Yeah, we have software developing experience, of course. I think if you haven't developed such a product by yourself, it's quite hard to take some decisions to gather the advantages and the advantages in detail. We do some prototyping for some smaller tasks. We are also able to test a quick solution, but in a larger scales, of course, we have function developers behind us, with us, which are faster in developing specific solutions with our current tool environment and so on. So we are a combined team of architects, software developers, integration engineers, and test engineers together to be able to provide one common product.
Okay, and like that was an interesting situation before when you chose option 1 and you chose option 2. In such a case, how is the decision-making process to come to a result? Like, is it then just the person with the higher job level or salary range that decides, or how is the decision-making process there?
I mean, basically you design or you have defined different business criteria for your project and also for your platform. Yeah. And based on that, you basically take the decision. You evaluate against them what solution would fit better with respect to the timeline, availability, and on the other hand, on the, for instance, risk I take, yeah, and this is something how you try to balance it out. So it's more a way that we provide the methodology to do that and less that there's always a one answer, yeah. And I mean, we had that in several topics. If you really clearly analyze it, and this is the point, you bring all colleagues on the same view and you get basically structured in the same way. Otherwise, if you just take a decision, yeah, I mean, it's always like that. You get people not on the boat, unsatisfied, and the issue might not be solved that easy. So providing a clear way how to come a decision where everybody can agree on, this is one of the toolkit what an architect requires at that point. Yeah.
Okay, good. Yeah, I mean, it's good if everyone is on board.
Yeah.
So, any more questions from the audience? Here, just a second. That's Karina with the mic. She was also fully responsible for organizing these events. Thanks, Karina.
From a personal experience perspective, what is an alarm signal for not well thought through architecture for bad architecture? Or what are 2 or 3 alarm signals?
Examples of a bad architecture, for instance, where you can see them early, yeah? Okay, I try to make an easy example, yeah? Think of our engine control systems, what we have. If you would get a typical requirement from the customer, like you say, I would like to basically improve the balancing between, in a hybrid system, between the electrical system and the combustion system, for instance. And if you now have a setup in your system that you need to break down the requirements on 20 impacted subcomponents, meaning 20 people have to develop, have to verify, have to integrate everything, it's less suitable than if you just would have to split it down in 2, for instance, right? So this could be one clear view that if you get that request once, you might not really care, but if you get it 100 times, then it's clearly less effort and less risky to have a better architecture here. That's one example. Second example, what typically happens with the topic of evolutionary systems. You might have a clean architectural structure in the very beginning, then you take your first shortcut, yeah? Then you take your second shortcut, and at some point in time you have clearly intertwined systems, yeah? Which means that even you get such high interdependency that changes on one has so much high impact on the other system, it's really difficult. Yeah? So keeping here a clear structure out is one topic as well. A third example, and then I finish. A third example would be from a platform design. Yeah? If you don't clearly separate what is a specific requirement for a customer, and you are able to separate that out of your platform solution. Instead, you incorporate it in your, then every other customer not caring about that is getting basically a takeover issue with that one. Yeah, so in Germany we say Beifang. Yeah, so basically, and this leads to all additional effort in the other project. Yeah, so I mean that's maybe 3 examples where you see in different ways how a bad architecture might not ruin your product, yeah, but it brings definitely inefficiency to your product, yeah, and this design to make it clear and to keep it up over time in an evolving system, this is one of the challenges what we see actually over here.
There's also one important indicator for me. So if I create a system architectural design, for example, and I'm not able to tell my colleague next to myself the background of this design, if he doesn't understand it quite easily, that's also always an indicator of a bad architectural decision. So that's an very easy indicator for ourselves to check this. So if I can't explain it to a child, then it's most likely a bad decision.
Or to a duck.
Maybe.
Actually, I learned it's a 3C, right? Yeah, so it's customer, CEOs, yeah, and children. Yeah, so
Okay. Okay. Last two questions before we go further. Like, you're talking a lot about requirements and customers and so on. And there is one question, like, how do you connect the sales team to developers? And I would kind of rephrase the question a bit, like, how you make sure that the requirements are basically, valid and relevant.
would you like to start?
Yeah, there are some methods which we use. So we start with a requirements elicitation process where we evaluate the customer requirements, go into discussion with the customer and talk about the requirements with them. And then we ensure the consistency over traceability. So we ensure that every customer requirement is linked to system and software requirements further on to ensure that everything is covered in the final project and we didn't lose anything on our way.
And I mean, basically the point is also, if you would like to ensure some kind of reuse of your own thoughts, concepts, what you have done, you have the challenge not to take the customer requirement one by one, instead understanding what the need is and translating it as best possible to solutions which are already there is the first entry point to be able to have some kind of reuse of your position, what you have at that end, in order to not invent everything again in every project, which is actually the idea of a tier one, to be in that position more competitive. Yeah?
There's even an advanced method then. So if I use such a method like we showed it before and I create a functional view of the architecture with a state chart, for example, we're even able to find out missing customer requirements. For example, states he didn't consider in his requirements to us or any other gaps, missing interfaces and this kind of stuff.
So it's not about only taking what the customer brings, it is supporting the customer bringing it to a great product. That's basically the point.
That's very nice. And then last question from Mohammed. He's asking, what skill sets would really make impact for architects in the automotive industry? So we had it here generally, like for architects, but specifically for the automotive industry, what's the impact of architects?
So from my perspective, the most important skill set for an architect is the communication skill. So you have to be able to bring several guys together, even from different opinions, to get a common understanding on the problem, to abstract topics and to get an overview of things.
Exactly. So, I mean, you need definitely some kind of basic attitude to structure, and also some kind of basic education for architecture is definitely helpful to come into that point. And besides that, it's more about the toolkit, and communication is the most important one to bring that, discuss that, negotiate that with the organization. Architects are not the single point of wisdom, but they are those colleagues who generate that best solution for the company by providing the right views on the problem.
Cool, thanks. That's some nice last words. So thank you so much for your session, for your presentation.
Perfect.
I think you'll be around, so people can ask you questions later on.
Feel free to
as well. Thanks, and see you later.
Okay, thank you.
Thank
Bye.
you. Bye.
Josie.
Yes.
There's also one question for you from Mr. Anonymous, or Miss Anonymous. Is a university degree a must to work in this field at Bosch? Would a skilled candidate without a degree be considered when recruiting new employees? So you're working in HR at Bosch?
Yes, I am. No, master degrees is not knockout criteria. So basically we have in Austria the special education HTL called. We have bachelor degrees, we have master degrees, and mostly the experience and the knowledge and the passion about automotive are the things what we are looking for.
So experience wins over degree.
Yes.
Perfect. That's good. Good. Then you have to help me. Are we going to a very short break now, or are we announcing our next speaker?
I'm not sure. I think we have at 4 o'clock the second session, so
Yes.
we have 5 minutes.
Okay, then let's
Should
grab
we
a coffee.
break 5 minutes break, and then we start at
Okay.
4 p.m. with the second session.
Perfect.
Good. See you in 5 minutes.